All right, in class last time we looked at both section 1.6 and 1.7. 1.7 is really important. I just wanted to go ahead and do a video related to what we did. So expressions is what we're working on throughout chapter 1. Okay, they don't have equations in them. When you have an expression, you usually are going to simplify. Sometimes you evaluate it, okay, or find the value of it. Okay, equations, that's what we're doing in chapter 2. These have equal signs. With these, you typically are going to be solving them, or later you'll wind up graphing equations in 2 variables, okay? Now, there's some vocabulary that I'm going to be throwing out there, so I just want to make sure that I mention it. And it kind of helps you when you're looking at these expressions that have lots of numbers and variables to try to make sense of it. So I want to jump down for just a second to this problem right here. All right, do you see how you have several things that are being added and subtracted? Okay, the various pieces that are being added or subtracted, you've got this piece, you got this piece, and then you got that piece. Those are called your terms. Okay, so the whole thing is called an expression, and then the pieces that get added or subtracted, the things being added, subtracted, things being separated by being added or subtracted are your terms, okay? All right, and then notice that you've got these terms like the 15p squared is a term. And see how it has a number, it has a 15, and then it has the variable part, the p squared part. This right here is the numerical coefficient. So when they talk about the word coefficient, they're really usually talking about the numerical coefficient, which is just the number in front of the variable part. And then one of the things you have to be careful about is when you have like that second term, that's really negative 7p squared. So the numerical coefficient there would be the negative 7. Okay, so 15 is the numerical coefficient here. On this one, the numerical coefficient is negative 7. Make sure you include the sign. And then the p squared is the variable part. The way to think about these in a minute is we're going to be being asked to simplify expressions. So we're going to have to look at something and see if we can put together some of these terms, if we can go ahead and combine them. And what it's going to take is your terms are going to have the same exact variable part, the variable and the exponent on the variable. So for instance, on 1/16, since these are all p squareds, we're just really adding up, figuring out how many p squareds we have. So this one's going to be, well, we had 15, and when we took away 7 of them, we only had 8 p squareds. Then when we add 8 more p squareds, that's going to turn out to be 16 p squareds. Okay, and that would be what it means to simplify that expression. Okay, all right. So I want to back up just a minute and work a little more with the vocabulary. So 17 through 32 is just asking you to give the numerical coefficient. Okay, so some of them are going to be obvious, like on 17, that's going to be negative 12. All right, and I'm just going to do these 4 right here, the first 4. On 21, there's an understood 1 out in front of that xw. So 1 would be the numerical coefficient. And by the way, the reason I could just slip a 1 in there and put 1 times x times w is because 1 is the multiplicative identity. So it really hasn't changed it to do the 1. All right, with 25, the numerical coefficient of x is actually understood 1 on top with the 2 on the bottom is actually going to be 1/2. These are kind of hard. Let me do another one. That one would be 1/6. This one would be 2/5, and the numerical coefficient on 28 would be 8/9. Okay. Also, let me back up and look at 24. On 24, the numerical coefficient would be -1. All right, and then with 29, the numerical coefficient would be a -0.5. Okay. You could say that 10 is the numerical coefficient in a way, because it's almost like it has an understood x to the 0, but you normally don't see them talking about that, and we just call those constant terms, okay? All right, now 33 through 40 are kind of important. Here we're trying to determine if the terms are like terms or not. Okay, it's kind of like, you know, when you're adding fractions, if I were adding like 2/7 and I wanted to add a fraction to it, I meant for that to be a 7. They have to have like denominators to be like fractions. We actually use that word, and then that means you can add them easily, and that would be 5/7 because those are like fractions. Later, you'll learn about radicals. You might have something like 2 square root of 7 plus 3 square root of 7. It'll turn out you can combine those because they're like radicals, and that'll become 5 square root of 7. And then now we're dealing with these variables. So like say you had something like 2x to the 7th plus 3x to the 7th, because the variable part's the same. These are like terms, we call it. And we can say that's going to be 5x to the 7th. With all of these, we're actually using the distributive property. We just don't usually make a point of writing that out. Okay, so to be like terms, you have to have the same variable part, the same variable, and the same exponent on the variable. So let's just circle the ones that are like terms. So these two could be combined because they both have x's. These aren't, because one of them is z to the 4th, the other one is z to the 3rd. So it's almost like you have 5 apples, but then 9 oranges, 9 something else, and so you can't put them together. These are not like terms. You can combine these constants. They're considered like terms. These are different variables. So again, you got apples and oranges. Those are not like terms, and neither are those, okay? All right, now let's go ahead and work, Sorry, I moved it and it misplaced those. Give it time to settle. Okay, so let's go ahead now and work a few of these. And on 115, see how it's 2 m's and then 9 more m's. That would just be 11 m's. They were like terms. You can combine them. All right. On 117, I really don't want you rearranging terms. So I want you just noticing that these two are like terms. Those two, they both have p squareds, and then these can be put together. This is a good time if you like to use different colors. It works really well. Like you could have used, change that to a blue. Like I could have used blue on this one, and then red on the other. And then when I put together the 5p squared and the 11p squared, that means I'm going to have 16p squareds. And then when I put together the -4 and the +6p, that's going to be plus 2p. And then that would be your final answer. All right, we already did 116, and that wound up being 16p squared. All right, with 119, you've got parentheses. So you have to use the distributive property to remove the parentheses. So this would be 14m plus 21. And then see on this next one, the 2 has a negative in front of it. So that would be negative 16m. And then -2 times -4 would be positive 8. Okay, then you look at how the 14m and the -16m can be combined. It would be much better if you had more space, but I just can't space these right now. And that would wind up being -2m. And then see the 21 here and the 8 there would become 29. Okay. All right, let's go ahead and do the 118. I'm going to erase this over here to the side. We have to distribute on that one too, don't we? So we're going to distribute the -2, then we're going to distribute the +2. So we're going to get -2 times a +3 would be -6k. -2 times -5 is +10. 2 times k is 2k. 2 times 1 is 2. All right, and then we're going to combine the like terms. So that's going to become -4k, And then the 10 and the 2 would be plus 12. And then these can't be combined because the variable part's different. So you have to stop. All right, now for 120, I'm going to rewrite it down here. Okay. All right, so that one, I would slip an understood 1 in front of the parenthesis because that's 1 times, and that doesn't change the meaning of it. And then I would distribute the negative 1. So I'd have negative 2k minus 8 minus 3k plus 7. So you got to watch your signs. Then the negative 2 and the negative 3 becomes negative 5 because you're adding a negative 2 and a negative 3. 2 debts. And then negative 8 and a positive 7 would be minus 1. And that would be your final answer for 120. Okay. All right, I'll do 121 and 122 at the end. Wanted to go ahead and look at 5 and 6, see if we could figure out what this person was thinking. Let me get a little more space so I can move that up. All right, so let's look at number 5. So the student did something wrong. Part of the reason they made the mistake is if you try to write out too much, you drop stuff that's important. You drop signs and things. And so I really recommend you don't even do that second step. If you did, this would have to have a minus inside here. This would have had to have been minus 2 and then minus 2x. And they dropped the negative on the 2x, okay? What I would prefer you do is not even write that step and just notice that you got to do the multiplying, which means you have to distribute the negative along with the 2. Let me see if I can blow that up a little bit. So distribute the negative along with the 2. So say negative 2 times positive 3, that's negative 6. That part's good. Then say negative 2 times negative 2x would be positive 4x, just right then. And so you don't even write that second step. You'll be less likely to make that mistake, okay? So let the arrows be the reminder that the negative 2 has to be distributed to both terms. And then the 7x gets combined with a positive 4x, so you wind up with 11x minus 6, okay? All right, and then let's look at 6. 6, it's really common to make this mistake, but it is not correct. The problem here is, see that 3 plus 2 got combined to make a 5? But that meant you did the adding before the multiplying. And with PEMDAS, aren't you supposed to multiply before you add? So let's work that one out the way it should have been. You should distribute the 2. You should deal with this first. Leave the 3 for a moment. Then put the 3 together with the negative 10, and you'll get 8x minus 7. Okay. All right, so that was really an order of operations issue. It didn't do the distributing first. Multiplying before you do the addition. Okay. Over here, the problem was trying to write out too much. They dropped that negative. It was a sign error. Really easy to do that. Okay. All right, now let me back it up a bit and tell you how to approach these problems. Okay. I'm going to erase what we did over here for a minute, so I have a little more room. All right, so with 121 and 122, we're back to trying to translate something. We did this on a exercise set way earlier. Excuse me. I want to try to give you a way to think about it. Okay. These are pretty complicated. Okay. They want us to use x as the variable, and they want us to get things fully simplified. Okay. So with one like 121, I don't usually start at the left and move to the right. I look for where they refer to the variable. Okay. So it says 7 times a number subtracted from, that's subtracted from, so we have the times here, then subtracted from the product of negative 2 and 3 times the number. Okay, it's just too much to hang on to, isn't it? There's too much going on there. So just don't try to do the whole entire thing at once. Find where you see number, okay? Then back it up, okay? So now we have 3 times the number, so that would be 3n. Okay, then we have, back it up again, we have the product of -2 and that. The product of -2 and 3 times the number. Product is multiplication, so we have this, okay? All right, now this gets a little complicated because we have this whole subtracted from language. So let me put a hold on that for a minute and let me go back over here and look at this. This says, I got the number, that's my x. Oops, I'm supposed to be using x's. Sorry, let me change that to an x. All right, so I got my number, so that's x. 7 times the number, so that would be 7x right there. So I'm supposed to have 7x subtracted from -2 times the 3x. Subtracted from. So remember how we did like 10 subtracted from 20? The 20 would have to be first. So this should be first, and then we're going to subtract 7x from it. But you see, I didn't really just try to go from left to right. I looked for where they refer to the variable. Okay, same thing here. So here I have a number multiplied by 8, and then I want that added to the sum of 5 and 4 times the number. Okay, so I'm not trying to do it all. I'm just looking at the gist of things. All right, so x would be the number. 4 times the number would be 4 times x. You can write that as 4x. Keep going back. Now it says the sum of 5 and that. So here's the sum of 5 and 4x. Sum means to add. All right, then it has this added to language. So let's hang on a minute. Let's go back to the beginning where it said a number multiplied by 8. A number multiplied by 8. I would write that as 8x, okay? So now, the number multiplied by 8 needs to be added to the sum of 5 and 4 times the number. So if you had 10 added to 20, you would take the 20 and add to it. So what I'm going to do is add the 8x. All right, now I'm going to look at it. And now I'm to the point on these where I'm going to go back and do the last part, which said these needed to be simplified. So see how on 121, this would be -6x minus 7x, which would be -13x. That would be the simplified version. So they're going to ask for this, then they're going to want you to simplify. On 122, this was the expression we got when we translated, and then these were like terms, and so we would write it as 5 plus 12x. And 5 and 12x cannot be combined, okay, because they're not like terms, so you would leave it at that. Now they'll take it if you write 12x plus 5 because addition is commutative, but based on the way the words were, this is actually the way it was stated, okay? All right, so I just wanted to do a little bit more. This section right here is usually where I get a sense of whether somebody's really grasping what's going on or not, okay? Combining like terms. So let me do one more. So let's say you had -3x squared minus 5x plus 4 times x minus 2, okay? See what happens there. So we have to distribute. So that would be -3x squared, and then negative times a negative would be positive 15x. See how I'm not writing that step? I don't want you getting in the habit of doing this. I find that people mess up when they do that. There's no reason to do that. That's what the arrows are telling you. Then 4 times x, and then 4 times -2. Then you look at what you got, and you see if any of the terms have the same variable part. These do. And 15 is positive, so is the 4. You're adding those and getting 19x, and then you're just going to bring the rest of this along. So that would be your final answer on that. Okay, 1-7 is pretty important. Hopefully it makes sense to you, and you can do a good job on that homework.